This photo story will cover the first part of Chapter 13 in Tillery's Integrated Sciences. This will cover the terrestrial planets of our solar system. First of all, it's necessary that you understand how planets are formed. They're formed from what are called protoplanet nebulas, and there are different stages to the life cycle of this nebula. First of all, you should know that nebulas are the birthplaces of stars, but sometimes you also have planets that are formed. Stage A is when the protostar forms in the center. At stage B, the nebula will condense and the protoplanets will start to form around the star and revolve around it. Stage C is when the star is established, no longer called a protostar, and the protoplanets cool and become planets. The International Astronomical Unit is a group of scientists that have gotten together and decided on standard definitions when it comes to astronomy. First of all, they have the definition of a planet. A planet is a spherical object orbiting the Sun, large enough to clear all matter from its orbital zone. A dwarf planet is a spherical object orbiting the Sun, but it is not large enough, or its gravitational pull is not large enough, to clear all matter from its orbital zone. Small solar system bodies are other objects orbiting the Sun, like asteroids, comets, meteorites and meteors, and meteoroids. An astronomical unit is the common unit of measurement in a solar system. Astronomical units are the same as the distance from the Earth to the Sun. This is what 1 AU equals. The planets of our solar system are grouped into two categories: terrestrial, Mercury, Venus, Earth, and Mars, as well as the outer planets, or gaseous planets, Jupiter, Saturn, Uranus, and Neptune. Notice that Pluto is not part of this. It's no longer considered part of our solar system. The terrestrial planets tend to have rocky surfaces composed of heavy metals, whereas the gaseous planets are, as you may guess, mostly made out of gases. Mercury is the innermost planet with a highly elliptical orbit. It has a weak magnetic field, and so therefore it has no moon. Its iron core has a thin silicate crust, and it's visible in the night sky shortly after sunset or before sunrise. Mercury is about 0.4 AUs from the Sun, about half the distance that Earth is from the Sun. The Mercury year, the revolution period, is about 88 days long. The Mercury day, or the rotational period, is about 59 days long. You can see that the surface of Mercury is deeply cratered. Venus is often referred to as the morning and evening star. It's not a star at all, but it reflects the sunlight and it appears in our morning and evening skies. It exhibits phases, like the moon. It has an iron core with a small magnetic field. You can see from this picture that Venus has a very dense cloud cover. This is due to its thick carbon dioxide atmosphere with atmospheric pressures that are 90 times that of the atmosphere on Earth. The atmosphere is mostly carbon dioxide with high temperatures and very high pressures. Venus is 0.72 astronomical units from the Sun. Its year is about 226 days, and its day is about 243 days, so the Venusian day is actually longer than the Venusian year. It rotates on its axis opposite its motion around the Sun. Although the pressure on the surface of Venus is 90 times that of Earth's, it has been visited by several space probes, one of which, called the Venera 9 space probe, took a photograph shown here of the surface of Venus. On Venus there is minimal plate tectonic activity, unlike Earth. The surface is flat with rolling plains and raised continents. There are some large mountains with volcanic activity. For now, we'll skip Earth and come back to it in the next chapter. Mars is the last terrestrial planet in our solar system. Its atmosphere is composed of 95% carbon dioxide. It has polar ice caps that are composed of frozen water, and it does not have a magnetic field like Earth because of its solid core. Mars is 1.5 astronomical units from the Sun. The Martian year is twice that of Earth's, about 687 days, and the Martian day is about the same as Earth's, 24 hours and 37 minutes. The atmospheric pressure on Mars is very light, 0.6% of Earth's, because of its very thin carbon dioxide atmosphere. And its density is very little like Earth's. It's only about 1% that of Earth's. There have been numerous space probes that have visited Mars, and there is strong evidence that there was liquid water on Mars in the past. Here's a picture from one of the probes that have visited Mars, and you can see some of the Mars geology of the landscape. There are inactive volcanic regions, there are systems of canyons, there are terraced plateaus near the poles, and there are flat regions with impact craters. Here's a picture of Mons Olympus. It is 3 times as tall as Mount Everest, and is in fact the tallest known volcano and mountain in the solar system on any of the planets. The caldera, the central region of the volcano, is 53 miles long by 37 miles wide and about 1.8 miles deep. The outer edge is defined by a wall and escarpment that is about 4 miles tall. The Spirit and Opportunity Mars exploration rovers brought back these images of Mars' surface. They found that Mars is made of basalt rock and groundwater that is dilute sulfuric acid. The discoveries of these rovers confirmed that sufficient amounts of water have been present on Mars in the past, and perhaps life has been supported. However, other tabloid evidence, such as the face on Mars, do not establish that there was civilization on Mars. This is simply a geographic feature of Mars, as you can see on the picture on the right, that does not always appear. There are 2 major Martian satellites, or moons. Deimos, which means terror, is an asteroid that is captured by Mars's gravitational pull and is in the outermost orbit. Phobos, which means fear, is also an asteroid in the innermost orbit, and it is the largest of the Martian satellites. This ends Part 1 of Chapter 13's photo story. Proceed to Part 2, which covers the gaseous giants.